In this video, we are solving a system of linear equations, and you'll notice that this is a system that has three equations and it has three variables. So we're going to solve it algebraically using elimination, but we have a little bit of a problem because the bottom equation, the last equation, is not written in the correct form. Look at the top equation. We have the variable terms on the left and the constant on the right, which is great. The second equation, variable terms on the left, constant on the right. But the third equation, we have two issues. We have a variable term on the right side, and then we also see that we could simplify or distribute the left-hand side. So we just need to do a little bit of preliminary work on this third equation. So I'm going to go ahead and distribute the 5. So we'll have 5x plus 5z is equal to 2z plus 5. And then we're going to subtract the 2z so that we can bring all the variable terms onto the left side of the equation. So we're going to end up with 5x plus 3z is equal to 5. So I recommend that you rewrite the original system of equations so that you have all three equations listed in the correct form. Now I have everything rewritten, and you'll notice I've also left some spaces for the missing terms because the first equation just has an x and y term, but it's missing a z term. So you can see I've left a blank right here for that missing z term. And I recommend that you do that just to help you stay organized so that you can decide which two equations you want to start with. I would also recommend that you label your equations because staying organized is key. So I'm going to label my equations 1, 2, and 3. I also like to do that in a different color just so I can be sure I'm not accidentally using any of those numbers as part of my problem. I'm just labeling to stay organized. So I need to choose two of these equations. I want to perform elimination so that I can eliminate a variable. And really, there are three different options. I could do equations 1 and 2, 2 and 3, or 1 and 3. And I can also choose which variable I want to eliminate. So as I look at this and to decide what's the best route, I see if I were to take equations, let's say 1 and 2, then the only variable that they have in common would be a y. So I have a y and a 3y, so I would be working to eliminate y if I chose equations 1 and 2. Instead, if I were to choose equations, let's say 2 and 3, the only variable term they have in common would be the z's, so I'd be working to eliminate z, and I have negative 5z and positive 3z. Now, if I wanted to use equations 2 and 3, that would require a little bit more work on my part because I would have to multiply both equations by a number in order to eliminate the z terms. And then my last option would be equations 1 and 3. And if you look at equations 1 and 3, the only variable term they have in common would be the x term. That would be the 2x and the 5x. And again, that would be a little bit more work because once again, I'd have to multiply both of those equations by a constant in order to eliminate the x term. So I'm going to go with my initial choice, which was 1 and 2. I'm looking at the y terms, and you see because it's just a 1y in the top equation and a 3y in the second equation, I'm going to be able to do elimination by simply multiplying the top equation by a negative 3, and that's going to be a little bit less work for me. So again, trying to stay as organized as possible, I'm going to come over to the side and I'm going to notate that I'm using equations 1 and 2. I'm actually going to rewrite equation 1, which was 2x plus y. I'm going to leave that space for the missing z term. And equation 2 was missing the x term, so I'll leave that space. 3y minus 5z is equal to negative 12. And now I'm going to work to eliminate the y term. So I'm going to multiply my top equation, both sides. I'm going to multiply by a negative 3. And as you begin to do more of these problems, you might find that you begin skipping some steps. But in this video, I really don't want to skip any steps. I want to be as clear as possible. So if you need to fast forward because you're not writing down every step that I am, that's fine. So my first equation, once I multiply by negative 3, will be negative 6x minus 3y is equal to positive 6. The bottom, the second equation, did not change, so I'm just recopying it. And now I'm going to go ahead and complete my elimination. So when I add these two equations together, we notice that the negative 3y and the positive 3y terms will subtract out. When I add straight down, we have negative 6x, because there's no x term below it, and we also have a minus 5z, and then a positive 6 minus 12 will leave me with a negative 6. So this is a new equation. It is in terms of x and z, and I would recommend that you label this as your equation 4, because it's a new equation. And it's, again, in terms of x and z, so now we want to find another equation that is also in terms of x and z. And this was just an interesting problem, because if we go back to the original three equations, equations 1, 2, and 3, you'll notice that equation 3 is already in terms of just x and z. So I will be able to put my new equation 4 with equation 3 and do elimination one more time. So I'm going to recopy my equation 3 and my new equation 4 to do my elimination. So equation 3, I'm not going to leave a space anymore for the y term. And the reason for that is because when you look at equation 4, we eliminated the y term. So it does not have a y term. It only has two variables. So here's my new system that I'm going to solve. And I want to eliminate a variable here. So I can eliminate either x or z. You'll notice in either case, I'm going to have to multiply both equations by a constant. So it really doesn't matter which one you choose. I'll go ahead and eliminate x. So in order to eliminate the x terms, we have a 5 and a negative 6 for the coefficients. So I need to turn that into a 30x for my top equation. So I would multiply by 6 to get 30. And then the bottom equation, to get negative 30x, I would need to multiply by positive 5. So again, I'm going to go ahead, stay as organized as possible, and rewrite my new equation 3 and my new equation 4, and then I will show the elimination. So 30x plus 18z is equal to 30. Negative 30x minus 25z is equal to negative 30. Now we go ahead and complete elimination. So adding these two equations together, I can see that 30x minus 30x will subtract out. We have 18z minus 25z, which will be a negative 7z. And then 30 plus a negative 30 will just equal 0. So continuing to solve for z, dividing by 7, I get 0 divided by negative 7, which is just 0. So now I have successfully solved for one of our three variables. But of course, I need to find both x as well as y. So now we're going to do what is called back substitution. We're going to take my answer here, z equals 0, and we're going to substitute it back into one of our previous equations. So we could substitute that back into equation, all the way back up here, into either equations 1, 2, or 3. We could also substitute that back into equation 4. We really have a lot of options here. It's totally up to you. We should get the same values no matter where we substitute it back into. So noting that I need both x and I need y, I'm going to go back to equation 4 just because it's right here. So here's my equation 4. I'm going to go ahead and substitute in our z value. So negative 6x minus 5 times 0 equals negative 6. Negative 6 then will equal negative 6. Dividing by negative 6, x is equal to 1. So now I have two values. I have both x and z, and now I need y. So looking back at the very top, the only equations that contained y were equations 1 and equation 2. And you can use either one. I like z equals 0, so I'm going to opt to come back here to equation 2. So I'm going to come down and recopy it again, just to be as clear as I can. So equation 2 was 3y minus 5z is equal to negative 12. But we have solved for z. We know that z is equal to 0, so I substitute that value back in. That gives me 3y is equal to negative 12. I divide by 3, and y is equal to negative 4. And now I have solved for x, y, and z. So my final answer is the ordered triple. Remember, we list our x, our y, and z here. So x is positive 1, y is negative 4, z is 0, and this will be the solution to our system of equations. Now, to visualize this, we could certainly use a number of websites or computer programs that will actually graph these three-dimensional planes for us. Just remember, what we're looking at here is we have 3 planes in space. Imagine a flat sheet of paper that extends forever in every direction. So we're looking at where these 3 planes intersect, and those 3 planes intersect at this coordinate, 1, negative 4, 0. One other way to visualize that is if you can imagine a box, like here's one plane, the front side of the box being a plane, then the top of the box, and let's say the right side of the box being the third plane, and looking at where these 3 planes all intersect, and they intersect here at this corner. So imagine that this corner in space, that could be this point, 1, negative 4, 0.